बिस्मिल्लाहिर्रहमानिर्रहीम। अल्लाहुम्मा सल्लि अला मुहम्मदिन व अला आलि मुहम्मदिन व बारिक वसल्लिम। रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वहलुल उक़्दतम मिन लिसानी यफ़क़हू क़ौली। Assalamu alaikum. I am Dr. Omar Farooq. By now you are very well aware of this fact that chemistry is all about matter. In the previous lecture, we studied about the particles that make up all matter. Today, I'll discuss with you various types of matter such as substance, mixture, element, and compound. The matter around us may be classified as substance and mixture. Substance is a pure form of matter while its impure form is called mixture. In chemistry, the word pure is used for anything that is made up of a same type of particles, whatever the particles may be. This implies that a mixture consists of different types of particles. A substance may be of two types, that is, element and compound. We'll define them later, but for the time being, an element consists of a same type of atoms, whereas a compound is formed by the atoms of different elements joined by chemical bond. A mixture may be homogeneous or heterogeneous. Whether it is homogeneous or heterogeneous, a mixture consists of two or more substances, which may be elements or compounds or both. Let us first define substance, the pure form of matter. A substance is defined in two different ways. Anything which has uniform chemical composition throughout is called substance, or anything which consists of same type of particles throughout is called a substance. If I erase the similar words, I am left with uniform chemical composition and same type of particles. So the concept is simple, that a substance has uniform chemical composition due to the presence of same type of particles. Textbook definition of substance is: a piece of matter in pure form is termed as a substance. Next, we define mixture, the impure form of matter. Mixture, the impure form of matter, may be defined in two different ways. Anything which does not have uniform chemical composition throughout is called mixture, or anything which consists of different type of particles throughout is called a mixture. If we erase the similar words, we are left with does not have uniform chemical composition and consists of different type of particles. So the point is clear that a mixture does not have uniform chemical composition due to the presence of different type of particles from different substances. These substances may be elements or compounds or both. The textbook definition is: impure matter is called a mixture which can be homogeneous or heterogeneous in its composition. Now we define element, the pure substance. Before defining element, let me recall you an important property of every element: atomic number, which is the number of protons in an atom. That's why it is also called proton number. Look at this atom. It contains 2 protons. So its atomic number or proton number is 2. Atomic number of an element is actually its identity number, which means that every element is identified by its atomic number, because every element has a unique atomic number and there are no two elements which have the same atomic number. So, the atomic number is the identity of an element, and we define an element on its basis. In very simple words, an element is a substance in which all the atoms have same atomic number, or an element is a substance in which all the atoms are chemically identical. If I delete the similar words, I get same atomic number and chemically identical, which means that the atoms which have same atomic number are chemically alike. That is, all the atoms of an element behave in a similar way during a chemical reaction. This is the meaning of chemically identical. The textbook definition of element is: it is a substance made up of same type of atoms having same atomic number and cannot be decomposed into simple substances by ordinary chemical means. Let me explain the last part of this definition. That is, an element cannot be decomposed into simple substances by ordinary chemical means. If we decompose something, we break all of its bonds by which its atoms are joined with each other. And if at the end we get similar atoms with respect to atomic numbers, then the substance is an element. But if we obtain different types of atoms having different atomic numbers, then it was a compound. To understand an element, let's have a deep insight into atoms. Look at these atoms and find their identities by counting their protons. First atom contains 1 proton, second contains 2 protons, third one contains 3, next contains 4, next one has 5, and the last one has 6 protons. As proton number is the atomic number of an element, so atomic number 1 is hydrogen, atomic number 2 is helium, 3 is lithium, 4 is beryllium, 5 is boron, and atomic number 6 is carbon. Since there are equal number of electrons and protons in an atom, therefore hydrogen has 1 electron, helium has 2, lithium has 3, beryllium has 4, boron contains 5 electrons, and carbon contains 6 electrons. First shell contains maximum 2 electrons. Therefore, next electrons go into the second shell, whose capacity is of 8 electrons. There is another particle present in the nucleus, and that is neutron, which acts like a glue for the protons. Recall that an element may contain atoms with varying number of neutrons. Such atoms of an element are called isotopes. Note this, here we are considering the most abundant isotope of each element. So the most abundant isotope of hydrogen is protium, which contains 0 neutron. Helium contains 2 neutrons, lithium contains 4, beryllium 5, boron 6, and carbon contains 6 neutrons. So the mass number of carbon is 12, boron is 11, beryllium is 9, lithium is 7, helium is 4, and the mass number of hydrogen is 1. Suppose this is a piece of matter and we wish to identify it. So determine its identity number, which is proton number. We found that each atom has 6 protons. So it satisfies the definition of an element, that is, a substance in which all the atoms have same atomic number. So this is an element named carbon. We have another example in which all the atoms have atomic number 11. Therefore, this also represents an element, which is sodium. Next we have atomic number 12, that is magnesium. Then we have aluminium with atomic number 13. Then silicon with Z value 14. And lastly, we have phosphorus with the Z value 15. So each element has unique atomic number. Let's see what is this. Each atom has 16 protons. So this also represents an element, and that is sulfur. Here we have two different type of atoms. Atomic number 11 is sodium and atomic number 12 is magnesium. So this is not a pure substance. Rather, it is a mixture of two elements, sodium and magnesium. This also represents a mixture of three elements. Atomic number 11 is sodium, atomic number 12, which is in large quantity, is magnesium, and atomic number 13 is aluminium. So this is also a mixture. But this is an element because all the atoms have same atomic number, 26, and the name of this element is iron. Next we have element having atomic number 29. This is copper. And finally we have atomic number 26 and 29. So this is not a pure substance. This is also a mixture of iron and copper. Next term to define is compound, the pure substance. Before defining a compound, you need to understand the difference between physical and chemical change. Consider the following process in which iron and sulfur are mixed in a china dish and kept at room temperature. What happens? No new substance is formed and we get a mixture of iron and sulfur in which both iron and sulfur retain their properties and can be separated with simple physical methods like using a piece of magnet in this case. Iron attracts with the magnet while sulfur does not. Such a change is called a physical change. If you heat this mixture, iron and sulfur lose their identities and a new substance, iron sulfide, is formed, which is a compound, and it is not possible to separate them by simple physical methods. Such a change is called a chemical change. Note that the first change was a physical combination or just a mixing process without any chemical reaction. But during a chemical change, chemical combination takes place. Chemical combination occurs when atoms join together through chemical bonds. So, a compound is a substance which is formed by the chemical combination of two or more different elements in a fixed ratio by mass, while a mixture is formed when two or more elements or compounds mix up physically without any chemical reaction in any ratio. A compound is a pure substance which can be defined in two simple ways. That is, a substance formed by the chemical combination of two or more different elements in a fixed ratio by mass, or a substance formed when two or more atoms of different elements join through ionic or covalent bonds in a fixed ratio by mass. I'm gonna erase those similar words again and left with chemical combination of two or more different elements and two or more atoms of different elements join through ionic or covalent bonds. This implies that when two or more elements chemically combine with each other, their atoms are joined through ionic or covalent bonds. The textbook definition of compound is: compound is a substance made up of two or more elements chemically combined together in a fixed ratio by mass. Here we have iron again, and this is sulfur. And look at this. Iron and sulfur are combined in a definite ratio. Such a combination is called chemical combination. And as a result, we get a compound. In this case, we obtain iron sulfide, whose formula is FeS, in which iron, being a metal, forms cation, while sulfur, being non-metal, forms anion. Next we have sodium element, and 17 atomic number means chlorine element, and they react to form a compound called sodium chloride. Its chemical formula is NaCl, in which sodium, being a metal, forms cation, while chlorine, being a non-metal, forms anion. The smallest unit of a compound may be molecule or formula unit. Here are some examples of compounds based upon molecules. This is water with molecular formula H2O. Here we have glucose with molecular formula C6H12O6. And this is sulfuric acid with molecular formula H2SO4. Each unit of these compounds exists independently as a single particle called molecule. Here are some examples of compounds based upon formula units. The smallest unit of these compounds, that is formula unit, does not exist independently. For example, this is sodium chloride with formula unit NaCl. Each formula unit consists of two ions, sodium cation and chloride anion. Here we have sand. This is an example of network covalent solid. Its formula unit is SiO2. This is potassium bromide with formula unit KBr. Each formula unit is a combination of two ions, potassium cation and bromide anion. Let's have a deep insight into these materials on the particles level, that is, on a very small scale. One thing to be noted in the figures to come is that a particular color represents atoms of a particular element. So you will find atoms of as many elements as different colors. As you know that a substance may be of two types, element and compound. If the smallest unit of both element and compound exists freely, it is called a molecule. If the smallest unit of an element does not exist freely, it is called an atom. And if the smallest unit of a compound does not exist freely, it is called a formula unit. Look at this figure. This is an atomic element, for example, neon. This is a molecular element, for example, bromine. This is a molecular compound, for example, water. This is an ionic compound consisting of positive and negative ions, which form its formula unit. For example, sodium chloride, whose formula unit is NaCl. Let us first examine the pure form of matter, that is, substance, which may be element and compound. Look at this figure. Here we have same type of atoms. Therefore, it represents an atomic element. Then we have a molecular element in which atoms of the same element are joined by chemical bonds to form molecules. So, this is a molecular element. The next picture shows molecules formed by two different elements. You see, in each molecule, Two purple colored atoms are joined with a green atom by chemical bonds. Now a question arises, why do I call them molecules and not formula units? The answer is very simple. As each unit is shown as a separate independent unit, that's why I call them molecules. So these are the molecules of a compound. Mixture is an impure form of matter which either consists of elements or compounds or both. Look at this picture. It is a mixture of two atomic elements. Next is a mixture of two molecular elements. In the third figure, there is a mixture of two elements. One consists of atoms and the other consists of molecules. Look at the next figure. This is a mixture of an element and a compound. The blue atoms represent an atomic element, while purple colored atoms joined with a green atom represent molecules of a compound. Next, we have a mixture of two compounds. And lastly, we have a mixture of an atomic element, a molecular element, and a compound. A mixture may be of two types, homogeneous and heterogeneous. In chemistry, the word homogeneous means same composition throughout, whereas heterogeneous means variable composition. Here you see that both type of particles mingle up uniformly. On the other hand, in a heterogeneous mixture, you observe that there is an unequal distribution of particles. A solution is an example of homogeneous mixture, and suspension is a heterogeneous one. Let's have some examples of various types of matter from daily life. On this slide, we have some examples of elements, and they are gold, silver, copper, aluminium, bromine, which is a liquid element, and carbon. Here are some examples of compounds, and they are water, glucose, sucrose, which is common sugar, and sodium chloride, which is common salt. This is pure water, the most common compound on earth, although it is rarely found in pure state. When you add pure water from a bottle into a glass, you are actually pouring H2O molecules only. Before moving on to the examples of homogeneous and heterogeneous mixes, it is better to understand these terms a little bit. Add a spoonful of table sugar into a glass of water and stir it. At first instance, you observe that sugar crystals settle down at the bottom. But as you go on stirring, these crystals gradually disappear and sugar molecules spread all around uniformly or equally. We say that sugar has dissolved in water. This uniform or equal distribution of sugar molecules in water is termed as homogenization, and we get a solution of uniform composition. So homogenization means that every part of water, however little it may be, contains equal number of sugar molecules. In simple words, every gram or cm cube of solution has same properties. For example, sweetness in this case. this is what the homogenization is. And as a result of homogenization process, we get homogeneous mixture. Following are some daily life examples of solution. First we have sugar solution. Ruafza in water has uniform color, taste and smell throughout. So it's a good example to understand solution. Then we have ink in water. Next is mineral water, so-called pure water. The mineral content is mentioned on its bottle. You can see over there. The tap water we drink is also solution, and its mineral contents vary from place to place. Next we have soft drinks. Besides their variable flavoring agents, they all have carbon dioxide gas dissolved in them. So they are also solutions. Here we have some laboratory solutions. This is ferrous sulfate solution. This is copper sulfate solution. Then there is potassium permanganate solution, and so on. A suspension is a heterogeneous mixture. Let me now explain the term heterogeneous. Put some blackboard chalk in water and stir it. Does it dissolve in water? Of course not. Similarly, add some sand or soil in water. They also remain undissolved, and if allowed to stand for a while, they settle down at the bottom of the container, forming heterogeneous mixtures. Moreover, the particle size is large enough to be seen with naked eyes and can be filtered off easily. These above mentioned heterogeneous mixtures are also called suspensions. So, in a heterogeneous mixture, the particles are not equally distributed throughout. Every suspension is a heterogeneous mixture, but the reverse is not true. That is, every heterogeneous mixture cannot be called as suspension. Confused? Let me explain. A solid or a gas mixed in a liquid without dissolving forms a suspension. For example, muddy water. It means a mixture of solids is not a suspension, although it is a heterogeneous mixture. This is a heterogeneous mixture in solid state, and therefore not a suspension. Similarly, soil and sand by themselves are heterogeneous mixes. So the examples of heterogeneous mixes are soil in water, sand in water, flour in water, mixture of dry fruits, a mixture of stones. Other examples of suspensions. The liquids which need to be shaken well before using are all suspensions, like these fruit juices. Look at this juice bottle. The heavy pulp is settled at its bottom. So, shake it well before use. Similarly, some medicines are suspensions, as you can see on their bottles. At the end, I would like you to know the difference between compound and mixture. A compound is formed by the chemical combination of atoms of different elements, whereas a mixture is formed by simple mixing up of substances, that is, elements or compounds or both. The constituents of a compound lose their identities and form a new substance having entirely different properties from them, whereas mixture shows the properties of the constituents, that is, the constituents retain their properties. Compounds always have fixed composition by mass, whereas mixtures do not have fixed composition. The components of a compound cannot be separated by physical means, whereas the components of a mixture can be separated by simple physical methods. Every compound is represented by a chemical formula, but a mixture consists of two or more components and does not have any chemical formula. Compounds have homogeneous composition, whereas mixtures may be homogeneous or heterogeneous in composition. Compounds have a sharp and fixed melting points. On the other hand, mixtures do not have sharp and fixed melting points. If you have any questions, please do write in the comments below. Thank you.